All right, welcome back, everyone. I'm glad you joined us. I hope today's lesson 5.2, day 2 on substitution, things become a little bit more clear. So hopefully by the end of the day we can say I can solve systems by substitution. All right, a couple important standards for us right there. All right, so hopefully we're at a 3 or 4 by the end of the day. Yesterday we talked about substitution when we had one variable shown. Okay, just real quick recap. If I'm doing number 1, this y is all by itself. So what I'm going to do is I'm going to take that and plug it in for y in the second one. Okay, I'm going to rewrite the second equation as 3x plus y equals 6. But instead of writing y, I'm going to write 5x minus 2. The point in this is it gets rid of one of those two variables. Both equations had two variables before, so we couldn't solve for it. But now we only have one variable. We only have an x. So when we do our distribution and solve for x, it's a real quick and easy way to get there. This is going to be 8x minus 2 equals 6. So when I add 2, you get 8x equals 8. Guess what? X equals 1. When you find those, that's only half of your answer. That's only the x coordinate. So then what you got to do is go back and plug that in the front. Okay? Now, the thing that helped me the most with all these is the way I organize things. Do you see how I circled up at the top here? I circled 5x minus 2, and I physically showed that it went down to that y. Because if you just follow the arrows, it's kind of just a pattern then. Okay? And once you get down here where you solve for one of those variables, plug it back into your one that you circled at the top. I find that helps me organize a little bit. Okay? And then once you do, you plug it back in for y. So y equals 5x minus 2, but x is 1, so it's really y equals 5 times 1 minus 2. Therefore, it's 5 minus 2. Oops. Therefore, y is 3. Boom. There's my answer. Yeah! Okay? So, that's the general pattern. Today, unfortunately, guys, it's going to get a little bit trickier. So, just to make sure we got that down, let's just do number... Payne Doty, which one do you want to do? Number 4? Sure. Okay? Let's do number 4. Alright? Do you notice any variable that's all by itself? I do, right here. It's 3x minus 7. Okay? So since that 3x minus 7 is what y is, I'm going to plug it in for the y in that equation. Therefore, when I rewrite the next equation, it's 5x minus 2 times y equals 12. But instead of writing y in there, I'm going to write 3x minus 7. Okay? Distribute all that good stuff out. Bloop, bloop. 5x minus 6x plus 14 equals 12. Why is it plus? Because it's a negative times a negative. Don't forget that. Okay? Oops. 5x plus 6x. Making mistakes here all the time. 5x minus 6x plus 14 equals 12. Combined like terms, that's going to be negative 1x plus 14 equals 12. And I add minus 14 to both sides. And then negative 1x equals negative 2, so therefore x is equal to 2. Okay? That's half my answer. How do I find the other half? Well, I go back and plug that into what I circled up at the top. So that's going to be y equals 3 times 2 minus 7, which is 6 minus 7, which is negative 1. That's my answer. Okay? Got that? Good. Today, we're going to add another step to it that hopefully you guys can figure out pretty easily, right? So if I do that, this 5.2 day 2, if you're looking at letter A, the one we're starting on, do you notice that any variables are by themselves? If they are, that's easy. That's what we pick. With this one, you'll find, hey, no variables are all alone. I have a 2x, I have a 2y, I have a 1x, and I have a negative 4y. There's no variables that are all by itself, meaning like an x equals something, or a y equals something. That's what we want, because then we just substitute that in. Okay? But we don't have that in any of those cases. So what we need to do is get one of those into that. I'm going to pick this one. Why am I going to get that one by itself? Because it's already just a 1, and so it's going to be really easy to rearrange it. So just one additional step for these ones. In order to get that 1x all by itself, I'm going to need to add 4y to both sides. Okay? That cancels. Now I have x, or 1x, equals, I'm going to write the y first, but 4y minus 1. This is now replacing that entire equation. So now I just look, I have equation up there and this equation. And now do you have one variable all by itself? Why, yes, I do. So I'm going to plug in that x in for that one right there. And now it's the same steps as yesterday. Okay? So rewriting it, 2x plus 2y equals 3. But what am I writing instead of x? I'm writing 4y minus 1. Priscilla, why am I writing 4y minus 1? Why did I do that? Because now look, we have two of the same variables. They're both y's. And so I can solve for that when I only have one of those variables. Okay? So we're going to loop this out here, distribute it out. 8y minus 2 plus 2y equals 3. Logan Ends, can you combine your like terms? Yeah, you can, because you're smart. All right? That gives me 10y minus 2 equals 3. So when I add 2, I'm going to get 10y equals 5. Don't say the answer is 2, because it's not. It's divided by 10. It's going to be 1/2. Y equals 1/2. Okay? This is one of the benefits of substitution. I wouldn't know it's 1/2 or 0.5 or whatever if I was graphing it, but now I can figure it out algebraically. And now that I have my y equals something, I'm going to put that back in for y in one of the other equations. And it doesn't matter if I do this one up here or this one down here, but that second one's going to be the better one, because look, we already know what y is. So to find out what this x number is, we're going to say x equals 4 times y minus 1. But y is, in this case, 1/2. So that gives me 2 minus 1, which we all know is the number 1. All right? So that's my answer to where those two lines cross. Make sure you write your answer as a coordinate, because that's what we are doing. Okay? We're finding out where those go. All right, people? That's one problem. We're probably only going to do a few more. So let's take a look at which one we want to do. Cody Norton, you got a choice? D, E, or F? What's that, Cody? Oh, you picked D? Perfect. Good choice. We're going to do letter D. Okay? Do you see a variable that's all by itself? Nope, I don't. So I'm going to get one that way. So if I look at it, I have a 1, I have a 2y, I have 3y, a 5x. You always want to look for the ones that have 1 on them, because those are going to be the easiest to get all by themselves. So if I take this equation, if I were just to minus 2y to both sides, right? This top, I'll just write it below. This top equation is going to be y equals, or x equals, negative 2y plus 1, right? Now I can basically disregard that entire top equation, because I have it rewritten right here in a nice way. and I have that equation. So I'm going to use substitution. I have a variable all by itself, so I'm going to plug that in for x. And when I rewrite it, it's going to be 5x plus 3y equals negative 23. But instead of writing x, of course I'm going to write minus 2y plus 1. Okay? When I distribute, negative 10y plus 5 plus 3y equals negative 23. Combining those like terms, looks like I got negative 7y. And I'm going to just minus 5 right here. Negative 7y equals, it's going to be negative 28. Hopefully I can all see what the answer is going to be. A nice integer for us there. Y is equal to 4. Okay? I'm going to come out to the side and write my answer there. Y is 4. That's the second point, because if you remember, we got x comma y in our answer things. All right? How do I find x? I have two equations up here. One of them's really easy to plug it back into. Oh, the second one, because it already has what y is. That's our easy one. We're going to have x equals negative 2y plus 1. And y is, of course, 4. So this gives me x equals negative 8 plus 1, which gives me negative 7. And that's my answer, ladies and gents. Just box it just so you make sure, hey, that's how I write my answer. Do I write this, and that's my answer? Nope. Do I write this, and that's my answer? Nope. I combine them and make one of these really cool looking boxes. Maybe put some stars on there. Maybe say, yeah, right? Because we got it. All right? Nice job, ladies and gentlemen. Those are two examples. Hopefully they're making a little bit of sense. Uh-oh, special cases. Let's talk about these ones real quick. What should we do, A or B? Let's go with letter A. Boom. All right, first question. Do you see a variable all by itself? I do not. Therefore, I need to get one all by itself. I see a 2x. I see a negative 4y. I see a negative 2y. Which one's easy? This one right here, because it's a 1. 1x is all by itself. That means that's what I'm going to move and rearrange it all by itself. So therefore, to get this one all by itself, I just need to take that piece and move it over there, right? So how do we move a negative 2y? Add 2y. Okay? So I'm going to add 2y to both sides, and I get x equals 2y plus 3 is equal to x. I can basically disregard that entire first equation because I have what x is. This is what I wanted. I wanted an x all by itself, so I'm going to take that and substitute it in for the x. Okay? When I do that, it looks like this. 2x minus 4y equals 6. And instead of writing x there, I'm going to write 2y plus 3. Abby Vincent, why did I write 2y plus 3? Because that's what x is, right? And so if x is there, that's what x is. Now when I distribute, I'm going to find some interesting stuff. I'm going to get 4y plus 3 minus 4y equals 6. And when you combine like terms, guess what? Those cross out and you're going to be left with 3 equals 6. And you ask yourself, is that a true or a false statement? This one is, of course, false. It's all crazy. It's all false, all right? If I had $3 and you had $6, you would have more dollars than I would. So, it's false. What does that mean? It means if I were to graph these two lines, it means they would never cross. What does that mean as an answer? It means no solution. Circle that so you see it real nice and good, okay? So if you get a false statement, that means no solution. take a second there to catch my breath. Everyone make sense? Okay? If letter A was no solution, anyone want to guess what letter B is going to be? I have a feeling that it's going to be IMS. What does that stand for? It means infinitely many solutions. Okay? And I'm just going to kind of fast forward through this one. So I'm going to add y. Why am I doing that? Because I have a 1x. So this is going to be now x equals y plus 1. Ignore that top equation. I'm going to plug that in for x. Negative 3x plus 3y equals 3y plus 1. Bloop, bloop. Negative 3y minus 3 plus 3y equals 3. That cancels, that cancels. I get 3 equals 3. I think I see that negative 3 there, so maybe it is no solution. I think I made a mistake. Let's just pretend you got negative 3 equals negative 3. All right? We're gonna ad-lib that. You pretend you get negative 3 equals negative 3. Then it would be IMS. If you got 5 equals 17, then it's no solution. Okay? So you just kind of look for those. If it's a false, it's no solution. If it's true, it's IMS. Anything works. Okay? We're going to call it a day for that. If this is real, in-person class, I'd give you a homework and you kind of look like this. So you can go ahead and look through those. Let's just pretend you had to do this. And I'm going to encourage you to try to do these because that's the way you get practice. Let's just do number 2 and talk through it. What variable would you solve for? I'd get that one all by itself. Why? Because it's a 1y. So I would add 3x to both sides. And this equation would now be y equals 3x minus 7. Right? Then I would take that and plug it in for y. Okay? If you had to do number 1, what would you solve for? I would solve for that one. Why? Because it's an x, regular x. So I'd minus 2y, and I get x equals negative 2y plus 2. This is what I would plug in for x. Let's scroll down. Let's do a couple more. 5 and 6, call it good? If you had to do number 5, which variable would you solve for? I would solve for the 1x. So therefore I would minus 2y. And I'd get x equals negative 2y plus 2. I'd plug that in for the x. On number 6, what variable would you solve for? A little bit trickier on this one. I definitely would pick this 1y, but if you notice it's a negative 1y. So if I were to minus the 3x, I would be left with negative 1y equals negative 3x plus 4. That's not what I'm going to plug in, because I still have to divide by negative 1. And really what happens is it just goes to each and every piece. And so we're going to be left with y equals 3x minus 4. That's what we're going to solve and plug in for y. Okay? Now, I'm not showing the rest of those just for time's sake, because this is already getting really long, but all of our answers need to be written as a coordinate. The x-coordinate first, the y-coordinate second. Those are your answers. Okay? I hope this is making a little bit more sense. We're going to spend probably one more day on this and take a quiz on it coming up soon. So make sure by the end of that time that you're at an I-10 level that you're comfortable with, right? A 3 or a 4. So thanks for listening. You guys have a wonderful rest of your day. Take care.